So the main purpose of the fluid is nothing but, okay, so the whenever we have a solid object, I want to move the solid object from this point to this point. Okay, so in this particular case, okay, so in a solid body, each point in the solid body will move with same velocity, but it is not happening in the fluid. So that's why we are just reading the particular fluid separately. So as we have seen in this particular fluid, we'll talk about, in first model we'll talk about different fluid property. Okay, starting from its volume, then viscosity. You can clearly see in that. So low viscosity fluid will be thrown to the larger distance. Okay, and high viscosity fluid will be having a lesser flow. It will be dropping down in the same place as it came out, and will have the property of surface tension at the right side image. Okay, so whenever the water flows down, it will have a shape of spherical. Okay, so that is surface tension. Will have an interplanar distance between the molecule. Will have in the bottom image, and will have a pressure. Will have a pressure property. So we'll study all the fluid property in the first module. My second module, this is all about fluid statics. As I said that fluid mechanics having classification, there is fluid statics, fluid kinematics, and fluid dynamics. Okay, so this is the first module of fluid statics. That is, we are just measuring the fluid and its measurement. In second module of fluid statics, we'll have hydrostatic forces. Okay, as I said that we have water in the dam. Okay, so we know that whatever this particular water will create some force over the wall. How the forces over the wall, okay, what kind of forces and how much amount of forces will be acting over the wall. So this kind of uh, stationary fluid will creating some force over the some structures. How the structures can withstand that amount of forces, we'll see in this particular model. Okay, I have given the image of dam. Okay, how the water in the dam, okay, how the wall of the dam can withstand that much amount of force, that we'll see in this particular model. Then we have how the particular ship will float over the water, and we have different points like point of buoyancy, center of buoyancy, then we'll have meta center. So this kind of parameter we'll see in this particular model, that is buoyancy and flotation. And we'll have liquids in rigid body. I have given the image of the truck. Okay, how the water in the trucks will move based upon taking right turn or left turn. How the water in the particular truck, how the truck wall will get the forces based upon its motion. So that thing we'll discuss in the liquids in rigid motion. Then we'll have fluid kinematics. So fluid kinematics is nothing but I'm just considering the, as I said that fluid mechanics having different sections, that is fluid statics. So fluid statics was completed in the last module. We are just starting the module of fluid kinematics. Fluid kinematics is nothing but I am just considering the changes in the fluid property only, not considering its forces. If I am not considering the forces, that is fluid kinematics. If I am considering the forces, okay, so that is fluid dynamics. So here I am giving the image of the bird was flapping its wing. The meaning is whenever I'm just flapping a wing, I'm just creating some forces and pushing the particular air downwards. Okay, so that I have some changes in the fluid. Okay, if I am involving a force, okay, if I am involving some force and make changes in the fluid, that is fluid dynamics. If I am not considering any force, and I'm just stating its property, that is called fluid kinematics. So there is the changes between fluid kinematics and fluid dynamics. And after completing the three topics, that is fluid statics, fluid kinematics, and dynamics, I have to measure the flow. For example, I'm having an aircraft. So aircraft was moving through the air. and it is not only moving through the air, and the aircraft was continuously monitoring its velocity. How it's monitoring velocity is nothing but using pitot-static tube. Okay, how the flow can be measured and how can we detail its motion, that will be discussed in flow measurement. And flow through pipe is nothing but, so we are just talking about some kind of real flows here. Okay, ideal flows here. So in the case of whenever we just coming into the topic of flow through pipes, we will have viscous flow. Viscous flow is real flows. Okay. So, we know that whenever here in the wall we'll have some friction. So whenever I'm just moving further from the wall, we won't have friction. So that kind of studies we'll discuss. Okay. So whenever we are in the model of flow through pipes, we will talk about the viscous flows, and whatever, since we know that whenever we just talking about the real flows, we have some losses. Okay. So whatever the losses in the pipe system also we'll see in this flow through pipes model. And the boundary layer, as I said, that whenever at the wall, you can clearly see that whatever the particle in the wall, the velocity will be very less or zero. But whenever we move further from the wall, the velocity increases. Okay, so this is generally boundary layer theory. And so here I have given the definition of laminar flow. So laminar flow is nothing but all the points in the particular flow will be having same velocity. But whenever we just come down to the wall, the velocity changes. So whenever I am having same velocity, that is called laminar flow. Whenever I am having different velocity, that is called turbulent flow. Okay. So we will talk about separately about laminar flow, and we will talk about separately about turbulent flow. Okay. So I have given the example of water truck, that is fire truck. So fire truck is nothing but fire truck. Using fire truck, we can project the water towards the 10th floor. Okay. So whenever I'm having a laminar flow, since laminar flow is nothing but the velocity of the flow was almost constant throughout its point, so that we can use the laminar flow in the fire truck. But in the case of turbulent flow, the velocity was continuously changing across all the points. Okay. Whenever the velocity changes, we cannot project the particular water to the 10th floor. So that is the meaning of this turbulent flow. So the next module is dimension analysis. So whenever we are having dimension analysis is nothing but, so I have to design a particular aircraft. Okay, so in order to design a particular aircraft, I have to create a small model. After creating the model, I need to check the similarity between the model and prototype. Okay, so in order to analyze the similarity between the model and prototype, I have to use some similarity laws, that is geometric similarity, kinematic similarity, kinetic similarity. So that will be discussed in dimension analysis model. The next is external flow, drag and lift. So we'll having a different drag and lift forces in this particular model. Then we have a model of jets. Okay, for example, I'm just having a water rocket. Okay, so I'm just creating some pressure over here. Using the pressure, how I can generate how much amount of velocity at the edge cost. Okay, so this is all about jets. So we'll talk about the theory of jets in this particular impulse of jets module. And finally, we'll talk about different turbines and pumps. Okay, what is process, how it works, we'll discuss how its efficiency, we'll discuss the turbine and pump property in this particular model. Okay, so that's all about the summary. I'm just going to